So, hi everyone. My name is Andrius, and I'm a software engineer in the Corda platform team, as Mike mentioned. And today I'd like to talk about different consensus protocols in popular blockchains and how they compare and contrast, and also explain how consensus works in Corda. So my talk will consist of 3 parts. First of all, I'm going to talk about different types of consensus protocols used in blockchains. Then I'm going to contrast protocols used by public blockchains and private blockchains. And finally, I'm going to explain how the pluggable consensus works in Corda. So let's begin with a quick definition of what we mean by consensus here. So in computer science, the distributed consensus problem is a classic computer science problem where we have multiple processes trying to reach agreement on some specific data. And in blockchain, that essentially translates to the mechanism by which network participants can reach agreement on the current state of the ledger. And usually, the consensus protocol used is one of the key design aspects of a blockchain platform. So in recent years, with the proliferation of blockchain technology, there's been a lot of focus around designing better and more efficient consensus protocols. And we can commonly see 2 main families of protocols, so namely lottery-based, where the creator of the new block to append to the blockchain gets determined by chance, essentially, and voting-based, where members in the consensus network agree on new state explicitly. There's also proof of stake, which is similar to which is a popular alternative to proof of work, where the creator of the new block depends on one's wealth. But I'm not going to talk about it today. Instead, I'd like to focus on proof of work and PBFT, practical Byzantine fault tolerance, as they're famously used by different public blockchains, such as Bitcoin or Ethereum, and private DLT platforms or blockchains like Corda or Hyperledger Fabric. So let's talk about proof of work. The general idea is essentially to have a set of participants in consensus, so-called miners, that are racing to solve a difficult puzzle. And whoever solves the puzzle first gets to append the new block of transactions to the chain and collect miner rewards. The proof of work algorithm has been famously introduced by Bitcoin in 2009, but the actual context, the actual idea dates way back in the 90s, where there was a paper where there was a proposal for using a similar concept for battling junk mail. So in Bitcoin specifically, the actual puzzle is finding a hash that satisfies specific properties. So for example, you take the new transaction data, append a number, take the cryptographic hash of the combined data, and modify the number and repeat the same process until you get a hash that satisfies the requirements. So here we have the requirement to find a hash that starts with 4 zeros. And it needs a number of iterations. So the key aspect of proof of work is that it's hard to compute, takes some time, but it's really easy to verify. So whoever solves the puzzle can easily prove to everyone that they did it. And proof of work has interesting properties. So first of all, it's very highly scalable. There can be tens of thousands of nodes participating in the consensus round. It also allows anyone to participate. You can have anonymous identities, and there's no trust assumed. At the same time, it also has some issues. So for example, if two or more parties solve the puzzle roughly at the same time, there can be multiple blocks proposed roughly at the same time, and we can have a fork. And what that means, if your transaction is in one side of the fork, you're not immediately sure whether your transaction will be confirmed. And in theory, actually, there's never a 100% guarantee that your transaction is confirmed. But in practice, once you resolve the fork and you append more blocks to the chain, the probability increases to a practically acceptable level. As a consequence of potential forks, there's also higher latency in proof-of-work systems. And probably the number one issue is that it's wasteful in terms of resources, and it requires expensive hardware and consumes a lot of power. So let's move on to Byzantine fault tolerance now. So the actual term Byzantine fault effectively just means that a node in the system can fail arbitrarily and can exhibit some malicious behavior. And this family of protocols originates from database replication mechanisms. So in this example, we can see a service that contains a replicated state machine containing the state X. And we have multiple clients sending requests for modifying that state. So the goal of the consensus protocol and of the whole service is to order these client requests and apply them in the same order on every replica so that the state evolves consistently. And that is usually achieved with complex multi-phase commit mechanisms that involve voting. So here's an excerpt from the paper of BFT Smart, which is the PBFT implementation that we use in Corda. And this shows the normal operation where a client sends a request. It gets replicated to all the different processes, replicas of the cluster, and they have multiple communication rounds to kind of agree and to detect any malicious behavior. And once that's done, only then can they record it. And this is actually only the normal operation phase. If something goes wrong, there's some more complex protocols for recovering the data. And BFT, I guess the main advantage of BFT-based approaches is that you have transaction finality. So once a cluster agrees on the order of transactions and commits them and signs them, you immediately know that your transaction has been committed. And as another consequence, there's lower latency, higher performance, because there's no possibility of forks. And we also have low resource consumption, because there's no artificial puzzles that you need to solve. The limits of BFT, I guess the number one is the vulnerability to Sybil attacks. So a Sybil attack is where a malicious party can create multiple fake identities, join the consensus round, and effectively have the majority take up the majority vote. So all the other truthful parties get outnumbered. So in BFT-based systems, you generally have to pick the participants in consensus carefully, and they have to have well-known identities. Another limitation is scalability. So as this is traditionally database technology, it hasn't actually been explored beyond around 20 nodes. And due to the multiple rounds of communication and multi-phase commits, it probably wouldn't even scale beyond that. So the consensus clusters has to be restricted to a small-ish set of semi-trusted parties. So if we compare proof of work and BFT, and in this table, we could maybe say that BFT-based algorithms are superior because they provide finality, they give higher performance, and they don't necessarily waste resources. But they effectively both solve a different problem. So proof of work works great for public blockchains like Bitcoin or Ethereum, where, say, the aim of Bitcoin is to create a global, unregulated, secure currency. And BFT works well for private blockchains or permission blockchains, which try to effectively optimize existing business workflows. And there are some existing trust relationships and trust assumptions, and also some regulatory requirements. So now let's move on to the final part and discuss how we handle consensus at Corda. So one of the key differentiating features of Corda is that we have no global ledger. There's no global blockchain. So parties transacting with other parties only retain the data that's relevant to them. So for example, if Alice and Bob does transactions, then they each keep this directed acyclic graph of transaction chains. So the whole ledger is distributed among nodes. And the very good thing about it is privacy. So you don't necessarily broadcast and have to share your private transactions with anyone else. But then we have a problem. For example, if Alice has some cash and sends it to Bob, and also takes a copy of the same cash and sends it to Charlie, then Bob and Charlie will never know that it has been double spent. So we need some sort of mechanism to combat that. And that's where the Corda notaries come in. They're essentially uniqueness services that keep track of spent states and prevent any double spending behavior. And a notary service is a replicated state machine that keeps track of the input states. So you could imagine it as a, say, distributed map. But the caveat is that some of the replicas might be malicious. So let's go through an example how the whole flow works. So Alice and Bob first build a transaction. It could be a cash transaction, could be some non-asset transaction. Then to finalize that transaction, Alice has to send it to the notary that is dictated by the input states used in that transaction. So every input state, say every asset, has an assigned notary that gets assigned on issuance. Then the notary examines the transaction. It checks whether it has seen any of the input states in that transaction. If it's a validating notary, it also validates the transaction chain up to the issuer. And if it has seen any of the states, it returns an error. And if not, it will happily commit and sign the transaction and then return a list of signatures back to Alice. So this is where the finality comes in. The signature over transaction basically means that transaction is final. And Alice can send it to her counterparties or record it, put it in the vault, do something else. So another interesting feature in Corda is pluggable consensus. So effectively, you can have multiple different notaries in the same network at the same time, and they can be servicing same clients or different clients. So here we can see a Raft notary, the blue one. So Raft is similar to the BFC-based consensus algorithm, but it assumes that all nodes in the cluster are trusted. So it relaxes the trust model, and that makes the protocol for reaching consensus much easier and much more performant. So in some use cases where some parties have another set of parties that they always trust, you can use this faster notary. Then we have the BFC Smart notary, the green one, which runs the BFC Smart consensus protocol, as we discussed before. And it allows up to a third or less than a third of participants to be malicious. And any new notary can be introduced to a Corda network at any time. So for example, if there's a new algorithm, we can easily upgrade existing networks and add a new notary to that. And here you can see an illustration of a possible Corda network where, let's say, we have these groups of parties that are color-coded. And let's say there are some patterns where the group in the same color tends to transact more internally than outside with the other groups. And we can exploit the facts and have each group have their own notary, like a local fast regional notary, for example. And that doesn't prevent anyone from using any other notary. So the blue circle could use the green notary. But it just makes things more efficient. And we can also have some parties use both notaries or transact with parties from another cluster. But in that case, since each state has an assigned notary, they both need to decide on a common notary to use. And then we have a mechanism for essentially reassigning one of the party states to the new notary so they can use it. And yeah, the major benefit of this mechanism is that we can constantly look for new and better algorithms and upgrade existing networks and introduce new notaries. Any questions? Yep.
I was just wondering, doesn't Corda have an issue that the notary services themselves could be DDoSed? You know, like, is it, you know, when you're comparing and contrasting proof of work to, you know, there are other security vulnerabilities that might be there.
Yes, so with DDoS, so generally, since Corda is permissioned, you don't allow anyone else to enter the network. And if you have certificates authentication, that doesn't become a problem. And if you get DDoSed, it's by a known identity, a known member of the network, and you can track it.
How would you not, I don't understand, I mean, how could you not have public-facing IP addresses?
So you can, but effectively we use...
It depends how you configure your network, because you could have...
Okay, we can
Yes,
talk about it
yeah.
offline. I was just, because I've had people ask me that, and I just wanted to be able to explain it better.
Okay, because essentially, yeah, we have a certificate-based authentication, and that solves it. So one question over there.
So I was just wondering, how fast are your notaries? How many transactions per second?
So in theory, a protocol like VFT Smart, their paper claims they can handle about 80,000 of transactions per second, which is quite a lot. So far in Corda, we're still working on the optimizations. And we're hoping, so we're not going to reach 80,000 transactions, but we're hoping to reach a solid number. I can't really provide anything specific right now, unfortunately. But once we have more progress, we will probably publish some numbers. Over there?
Slightly related to DDoS, but how do you make sure that your notary node does not become single point of failure, regardless of DDoS or basically
Okay.
crashes? So because RAF has a whole election mechanism, right? But you don't necessarily use that.
So the question was, how do we make sure that a notary service doesn't become a single point of failure? So I guess that's where the trust relationships come in. So you can have a cluster of, say, 50 nodes. And if, say, 3 nodes go down, the cluster can still remain functional. And you can hope that if the parties are semi-trusted, they're not all going to collude and compromise the network. So the key is numbers and trust, essentially.
So what you're saying, the role of notary node is kind of floating, right? If one node goes down, the responsibility to become notary could be...
Yeah, so you can view a notary as a cluster or as a replicated database. So if one replica goes down, you can still use the other ones. And while there's sufficient numbers of replicas in order for the protocol to function correctly, then it's fine. So you can tolerate some faults. There's one back there.
Hi there, yes. So thing about Corda environments, they're set up so there's no middleman. I mean, there's no trust there. So to me, what would be more sensible would be to have more than one notary associated with a contract. That way, nobody who runs the notary can interfere with anything going on. Is that possible?
So being more than one notary for a single state.
Like a consortium of notaries, so that no independent entity controls the validating mechanism.
So I guess the key here is that a single notary is a cluster of different entities. So for example, you wouldn't have a single organization run a BFT notary. Say we could have a BFT notary of central banks of UK, Russia, China, US. And effectively, as long as they don't all collude, we can trust the cluster.
What stops you getting to that 80,000 theoretical maximum transactions per second?
80,000.
You
Yes, yeah. So we have, so Corda also has this concept of flows and the flow framework, where you can encode your business flows and they're checkpointed. So whenever, if both nodes go down at a particular moment, you can revive the flow and reset it. And I guess that checkpointing and those flows would limit the throughput slightly, because 80,000 is a raw throughput. But there's some layer of logic around the notary, effectively. Yeah. Okay.
You said that when an asset is issued, it has an associated notary.
Yep.
How can you guarantee that your asset doesn't outlive the notary, that every asset can be validated by a notary?
So the question was, how can you ensure that an asset doesn't outlive a notary?
Your notary, suddenly that notary is no longer valid, no longer exists.
Yes. So that's where the network and the usage agreements come in. So if you run a notary service, you need to, essentially you're required, before you terminate the service, to inform the network and have people and wait for people to reassign their states to different notaries. Because we have a mechanism for reassigning, and there could be some legal agreements to enforce that. There's one over there.
Who's the sort of organisations that are actually holding themselves out to run these notary services for the group network?
So I'm actually not involved in the negotiation of which organizations are involved in that. So, yeah, I can't really answer that.
So I think just to address that one, and we do have other experts in the room who can help us with that, but when you think about the technology perspective, is you can build your own. So there's this notion of, we talked about Corda nodes can all talk to other Corda nodes, but if you think about the controlling factor about who can talk to who, is the certificate authority that they all work with under. So you cannot trust somebody unless they are under the same certificate authority. And then you need to also recognize the same notaries as the trust element and be on the same network map to discover keys and legal identities. We call that an interoperability zone. So anybody can build an interoperability zone in the same sense that you could take any of the other blockchain products today and go build your own network. So I think we do have some thinking around that, but we'll talk about it at a later date, around the building kind of a global interoperability zone as it would be. And that does require some thinking about who the players are. But on the flip side, there's nothing preventing you today from doing the same thing as other technologies, creating your own permission network as we think of it. So creating a business network that has one particular function, and then they would determine who the notaries would be in that. So keep in mind this, oh, sorry.
And the follow-up question is, that's obviously new space. Is there critical mass around the offer of those services?
So I think and this is, oh, my microphone's not on. Sorry, I can hear myself. So I think this is quite an interesting topic, actually, and I think we'll probably follow up in a lot more detail in one of the architecture working groups on this. So we will have more on this. I would think of it, though, is as you form a business network, the business network operator will probably be the entity that would control who the participants are, as well as who operates the consensus service. And they themselves may provide that, or they may even push the architecture to the point where the participants operate nodes in the consensus service. So it's a very flexible architecture in that sense. James, sorry,
Yeah,
thank you.
Just to say also, you know, the idea with the notary services is the idea with notary services is that there should be many, not just one, and we're also interested in creating I guess, competitive angle, so that you know, they will come with different features and they'll effectively be competing with each other for usage. Also, different scenarios might mandate different different notary providers. But finally, the person to talk to about this is Todd McDonald, who was here earlier. I'm not sure if he's still in the audience, but he's probably downstairs at one of the other groups. But he's thinking a lot about how to build notaries that are provided by ecosystem partners as well.
Right, this one.
In a Bitcoin-like architecture, the nodes can't do that much damage because everyone can verify that they're honest. Does it work in yours as well, or as an outside party, you just need to trust that the notary cluster does actually not introduce malicious transactions and funds where they shouldn't be?
Yes, you effectively have to trust it.
So
But
it is important
from
to
the outside verified, there's no verification of the state.
So let's clarify. The notary itself can operate in two modes. One is a validating notary, and the other is a non-validating notary. And if you take the non-validating notary, they're simply providing oversight to the double spend of the states. So they will not verify the transaction history on your behalf. That's the responsibility of the parties to the transaction who have all the data available to them to do that same verification. Now, the validating notary is if you require the notary to go through and do the transaction history validation on your behalf. In that instance, in today's environment, you would need to pass the data to the notary so that they could validate it. However, I think this is one of the exciting areas where SGX comes in to assist us is you can create a validating notary. This is not possible today because the SGX technology is not deployed. But the validating notary would not be able to see the contents of the transaction, but will be able to assist in verifying the transaction. But the simplest way to prevent privacy leaks is to, I would say, trust but verify. Verify for yourself, and then trust that the double spend is taken care of by the notary itself. And that's really the role of the notary. It's the consensus around double spend, effectively.
But you need to have someone inside the circle.
Yes, so we have auditing mechanisms whereby you can detect if a notary is malicious. But the assumption is that you would pick the participants of the notary cluster very carefully, and you would trust them. And even so, if they act maliciously to a certain extent, like even less than a third act maliciously, then it's still fine. If more than a third, then it's an issue. Yeah, that's a trade-off.
What's incentivizing the notaries? Sorry, two things. So what's incentivizing the notaries? Are they getting paid out each time they're providing the service? And who's issuing the digital rights certificates?
What was the second part, sorry?
So there's two questions. Firstly, what's incentivizing the notaries? And who's issuing certificates? Two different questions.
Yeah, so there will be some probably service agreements, and whoever runs the notary will charge fees. Might be through external channels. As for certificates, it's a bit of a more involved question, since with the concept of business networks, so R3 holds the main certificate authority and issues certificates to all the participants and do some minimal checks just to verify the identities. But then network participants can form their smaller business networks and have their own certificate authorities, and that way limit who the smaller network transact with. So it's a flexible model, essentially. The first entry would be R3, but it's a very kind of low bar entry. There's one back there.
I'm thinking about the possibility, I don't know if that's realistic, to be able to deploy notaries to carrier in a public network in the same way that we deploy DNS server. The business model will be that they will provide that service to anyone who wants to use it, take a fee, but I don't know if the system now will support the load, or that will be not feasible at this moment.
Sorry, could you repeat that?
So I want to mean a telco carrier could deploy a notary that anyone can use.
Yep.
And I don't know if that's realistic at this moment. It's not designed or there will be many problems.
So you want to deploy a notary, say, right now somewhere that anyone can use, right?
In the same way that now we have the DNS, that anybody can use it.
So usually a notary will be deployed as part of some Corda network. So you need to join, say, either the R3 testnet, it can't really be standalone, because a Corda network is governed by the certificate authority, and it's a permissioned network.
Yeah, but if the certificate authority is the telco company, I don't know. Vodafone.
So right now, it's quite flexible. So you can pick, so a business network can pick its own certificate authority. So you could create your own Corda network with your certificate authority and accept people there that you kind of trust, and then deploy a notary. But it can't really be deployed publicly, standalone, and to be used by anyone.
Okay.
I think one last question, and we'll stay on schedule for the next.
Is the certificate authority a one-time operation, or is that a recurring part of the transactions that are occurring?
It's a one-time operation that enables peer-to-peer communication, essentially, yeah. There was one at the very back, I think. Last one, yeah. That
Hello?
question is a good idea.
I was just wondering what would happen with the state transitioning between notaries that were part of different certificate hierarchies, whereas some parties might not trust one of the, I guess, smaller consortiums.
Right. So in that case, if the notaries are part of different certificate authority networks, then they would need to come to some agreement and cross-sign certificates to allow the communication. But there's always some negotiation step where you need to find a common notary and enable the communication.
Excellent.
All right?
Thanks, Andrius.
Cool.
So I think